Hi all, my name is Juan, and today we present StyleAvatar, stylizing animatable head avatars, the result of a collaboration between Meta, KAUST, and Universidad de los Andes. The objective of this project can be described as given a drivable avatar and a description of a desired style, say by text or images, we run a stylization process that returns a stylized version of the avatar that is still drivable. For the system to be useful, we state 5 requirements. 1, a controllable level of identity preservation. 2, the fact that the avatar is still drivable after the process. 3, level of texture geometry disentanglement. 4, the fact that this system can work both with images or text. And 5, that this process runs in a reasonable stylization time. Our method, StyleAvatar, works on top of the instant avatar architecture introduced by Cao et al. In 2022. This architecture is an encoder-decoder architecture with explicit encoder branches for expression and identity. In practical terms, given the identity on the top and the expression on the bottom, we render an avatar by processing the identity in the top with the identity encoder and the expression on the bottom with the expression encoder. The outputs of this process are then given to the decoder to render an avatar. In our case, we are interested in this process no longer generating the avatar corresponding exactly to the original identity on the top, but rather, for instance, to a zombie-style version of this identity. Broadly speaking, we have a drivable stylized. To have a drivable stylized avatar, we want to modify the architectural aspects related to identity without harming the aspects related to expression. For this purpose, we thus fine-tune only the modules that are here colored in blue. In detail, the architecture on the top combines a given expression described by CX here with an identity described by both a geometry and a texture map. The geometry and texture map are independently processed by 2 encoder-decoder architectures in turn. These architectures are responsible for generating 2 outputs, describing opacity and appearance that, when rendered, produce an image of the desired avatar. We can thus cast our target as fine-tuning these encoder-decoder architectures to fulfill our purpose. Here are the ones highlighted in red. We cast this stylization objective as trying to move the generated avatar towards the style that is described by a query, given by either a text or a set of images. We thus implement this by comparing the generated avatar with the stylization query in the representation space of clip to compute our loss and then backpropagate all the way to these modules. An additional difficulty we face is that the instant avatar architecture does not provide completely disentangled geometry and appearance, since the encoder-decoder architecture are not really independent, but rather connected by a set of bias layers. Thus, we achieve geometry appearance disentanglement by splitting the bias layers into 2 separate modules and pre-computing their inputs during the first forward pass. Finally, we combine our stylization loss with 2 regularizers. First, the identity regularizers. The identity regularizer controls the degree to which the stylized avatar differs from the original avatar. On the other hand, the symmetry regularizer avoids styles that induce asymmetrical artifacts around the avatar's eyes, which users may find unattractive. Here are some results. StyleAvatar, note, stylizes an avatar in a handful of minutes by optimizing the loss we described previously. This loss is stochastically sampled by sampling across expressions and camera viewpoints. Our pipeline thus produces appealing results both when conditioned on text, as shown here, or also when conditioned on images, as shown here. A notable capacity of a StyleAvatar is that the stylized avatars preserve the capacity to be driven. For instance, here the avatar can be seen when driven by a speech sequence by this person on the left, or here, where the avatar is driven by an expression sequence by this person on the left. In summary, we present stylized avatar, a method for stylizing animatable head avatars. Our method works by receiving as input a drivable avatar and a desired style given by text or query, and returns a stylized version of the avatar that is still drivable. A StyleAvatar thus optimizes the avatar by optimizing this loss in a matter of minutes, and it manages to preserve the avatar's driving capabilities, for instance, here in a speech sequence. Our method thus works across a wide variety of styles, identities, and points of view. Thanks for watching.